Okay, the question is the spring constant K is given. The data is being provided, the spring constant, this is the spring, okay, so this is given, and the mass of the block A is given, and the velocity, initially the block A is at rest, and the mass of block B is 10 kilogram, and the velocity is 15 meters per second. So these have been provided to us. So now how would you solve this in a conservation of linear momentum? So let's do one thing. I'm I'm going to show you that the linear conservation of linear momentum, how would you apply that equation here. So if you take a look, you have to make an axis here. Imagine this right hand vector is positive, so because the vector impulse and linear momentum, they are vectorial quantities. So over here in a linear momentum conservation's principle, I would just write it down outside the parentheses for both, equals to before the impact equals to after the impact. So now you can see here, so MA VA1 plus MB VB1, there are two masses, mass A and mass B. So before the impact and after the impact, the momentum remains conserved. MB VB1 plus MA VA2. I should have written here, this one term comes later, but it's okay, even the summation sign is here, it's okay. So assuming my right hand side is now positive, now the blocks couple together. The thing is, if you take a look, couple together means they become one block, so I can write down the mass as one block and velocity as one velocity. After the impact, they move like a single mass, so they move like a single mass either to the right or left. So let's find out that velocity. What is mass A? So the mass A is 15 kilogram and 0. Mass B is 10 kilogram and moving to the left. Let me show you, this is negative, look, it is moving to the left, so it's negative 15. So this is 0, so you're left with negative 150 equals to mass is, adding two masses is 25. So what do you guys get for this one? If we do the math here, 150 divided by 25, I got negative 6. The velocity v2 after the impact is negative 6, means it is moving to the left. So let me erase this vector and change the direction. So this was our first question. The first question was asked, this is not the first question. So the only question which they have asked is, what is the maximum compression of the spring? Now the maximum compression can be found applying the linear energy conservation principle. Let me show you what is energy conservation principle. So this is the energy is conserved. So let me copy this one, and so when the two blocks A and B, that block moves with a velocity v2 and to the left, it will come to rest. Final is v3. So let me show you, assuming this V2 is on the left hand, T2 V2 equals to TF VF. Maybe it is more clear now. So these are the two positions. Look, these are the two positions, and this is position number 2, this is position number F. Agreed? Now when the blocks, so what is the kinetic energy? T2 stands for the kinetic energy of both blocks, so it is 25 V2 square. And the initial spring, you see, what is the potential energy stored in the spring when it is just about to start its compression? It is unstretched. Try to understand. At position 2, the spring is still unstretched, so I can write down T2 as V2 equals to 0, because half K delta S square, where this is 0, delta S is still 0, it is still unstretched. But as it is moving to the left, over here spring is now very compressed. That compression needs to be found. This is our question. So at position F, so I can write down TF. Can you guys tell me, looking at the statement, can you guys tell me when this at position F, what is the velocity final? 0. It becomes at rest. It comes to rest after its maximum contracts the spring. So TF is 0. VF velocity, it is the potential energy, half K delta S. This is we have to find out what is this. So we know K is given. K is 10 kilonewtons per meter. So let me write down the left hand side here, which is what was our V2? -6. If you solve for this one, you can help your professor. So let me find it out for you. 0.5 times 25 times 36. It is 450 joules on the left hand side. So left hand side is 450 joules plus 0. The right hand side is 0 plus half K is how much? 10 kilonewtons per meter. So can I write down 10 kilonewtons, 10 to the 3 newtons per meter times delta S square. So one equation, one unknown. So can you find out delta S from here? It is 3.3 meters. This is the answer.